video is for section 5.8. We're going to be writing quadratic functions. So something that's important to know about quadratic functions, we're going to just look at the parent function, f of x equals x squared. So these are some points on the graph of f of x squared. So notice here we have equally spaced x values. So when that happens, we can look at something called the first difference, the second difference, the third difference, so on and so forth. So what that is, the first difference is the difference in the y values. So as I go from 9 to 4, I'm going down by 5. Then from 4 to 1, I'm going down by 3. 1 to 0, down by 1. 0 to 1, up by 1. 1 to 4, up by 3. 4 to 9, up by 5. So for linear functions, the first difference here would have been the same number, but we know that's not true for quadratics. They don't have the same constant rate of change. However, they do have something that is constant. We're going to look at the second differences. So what that means is the change in the change, essentially. I'm looking at the first difference. What's the difference in those differences? So from -5 to 3, they're going up by 2. Then -3 to 1, they're also going up by 2. -1 to 1, up by 2. 1 to 3, up by 2. 3 to 5, up by 2. So that is the second difference. So all quadratic functions have constant second differences. So it doesn't have to be 2, it could be another number, but it will always be the same number in that second difference column. Okay, so we're going to use that pattern to look at, are these functions quadratic functions? So we do have to make sure the x's are equally spaced. They are in both of these examples, so we can look at the differences in the y's. So from 11 to 21, they added 10. Then it looks like they added 14. Then they added 18. Then they added, 22? Okay, so that's the first difference. So let's look at the second difference. They went up by 4. Looks like they're going up by 4 each time in the differences. So because there's a constant second difference, this is a quadratic function. And where it says explain, we would say quadratic because constant second difference. Okay, all right, so let's take a look at this next one. So here, first difference, I'm going up by 2, and that's remaining constant here. So when I have a constant first difference, this is linear because constant first difference. Okay. All right, so now we're going to look at how can I write a function if I know that a quadratic function goes through some given points. So to do a quadratic, we do need 3 values. And here's kind of the process that we're going to use. We're actually going to use systems of equations. So what we're going to do is we're going to be given these 3 points, and a quadratic function goes through these 3 points. So I'm going to substitute these values in for x and y into this generic quadratic function in standard form. So I'm plugging in -3 for y and 0 for x. So we got a times 0 squared plus b times 0 plus c. So all of this goes away and I'm left with c equals -3. Okay? Okay, we're going to do the same thing for 1 and 0. So plug 0 in for y, 1 in for all the x's. So we get 1 a times 1 squared plus b times 1 plus c. So I want to arrange them so that I have a's, b's, c's, and then the constant. So I'm going to just rewrite this. So I have 1a plus 1b plus 1c equals 0. Okay. Then my last one, I'm going to plug in 2. So 2 for x, 1 for y. So we get 1 equals a times 2 squared plus b times 2 plus c. Simplify here a little bit. So we've got 4a plus 2b plus 1c equals 1. Okay, so here's my system of equations. So I have 0a plus 0b plus 1c equals -3. You'll see I'm writing like this because I plan to put them in a matrix in order to solve. And we got 4a plus 2b plus 1c equals 1. Okay, so now we are going to write that as a matrix. So I'm going to write it as an augmented matrix. Okay, so sorry, I'm going to have to do a little flipping back and forth here. So we had 0, 0, 1, -3 for our first row. Okay, our second row I think was a bunch of 1s and then a 0, yep. Okay, our last row is 4, 2, 1, 1. All right, so there is my augmented matrix. So to remember, we can use graphing calculators to help with this guy. Let's see if I can get that so I don't have the glare for you. Okay, so we are going to go to second matrix and we're gonna edit one of these matrices. I'm gonna use a 3x4 and I'm just gonna enter in those numbers. All right, so we got 0, 0, 1, -3. 1, 1, 1, 0. And what was our last row there? 4, 2, 1. Oh. All right, so we got our matrix A with all those numbers entered in there. So now what I'm going to do is I'm going to get out of that. So second quit. And we are now going to go to second matrix again. I'm going to scroll over to math and I'm going to find the RREF here, and then I'm going to select matrix A. So I'm going to go back into the matrix option, select matrix A. We already edited the values that are in it, and there it is. So that's, remember, my row reduced echelon form, and it gives me the solutions for those three variables. So I'm going to write that matrix here. So in row reduced echelon form, we got 1, 0, 0, -1, 0, 1, 0, 4, and 0, 0, 1, -3. So remember what this means. This row was A's, this row was B's, column. Column A, column B, column C. So this says 1A equals -1. So A equals -1. This row says 1B equals 4. And this last row says 1C equals -3. So we can write our, oh, I guess I had a spot for that, sorry. So we got -1, 4, -3. So my function in standard form would be -1x squared plus 4x minus 3. So this would be the function that goes through those 3 points that we were given. All right, that's it for this video. Thanks for watching.